Okay, so we have this question right here. It says Pluto is our dwarf planet in the outer region of our solar system. Pluto moves in an approximately circular path around the sun. The mean radius of the orbit is this. Calculate the intensity of radiation from sun incident on Pluto. So you have these two values. So the first step I always say is that identify your values, right? What values you have been given. So you have mean radius, which is Rm, and then you have radius of sun, which is Rs, and then you have surface temperature, which is Ts. Okay, and you need to find the intensity, right? What is the intensity? So then the second step is to identify the formula, right? What formula can you use? In this case, in this question, basically they told you what formula to use. So it is intensity of radiation. Intensity of radiation basically is equals to the L by 4 pi d square, right? So as you know that I don't have L, I have D, which is your Rm, right? If you don't know what Rm is, basically is you have this sun right here, okay? And Pluto is orbiting the sun in a circular path. As you can see, I have highlighted that as well. So basically the distance from sun to Pluto is basically your D, which is your Rm, right? Mean radius. Okay, so now in order to calculate L, we will use the formula of Stephen Boltzmann's law formula. Okay, so it's L is equals to this sine A T power 4. Okay, now this is the constant, so we can input the value Stephen Boltzmann's constant, which is 5.67 times 10 raised to power minus 8. Okay, and then you need to find area. Now this formula is basically used for the source only, right? Which is providing the intensity. In this case is sun, right? So all the values are related to sun. So basically the area for the sun, we will use the area of sphere, right? I want to say area of sphere. So area of sphere is 4 pi r square, right? So if we input it as 4 pi, r is radius of sun, which is 6.96 times 10 raised to power 8, right? And now the temperature, which is 5800, right, kelvins. And now if you calculate this value, right, this L value, you will get your answer as 3.91 times 10 raised to power 26 watt. Okay, now you can input the value in the intensity. So I is equals to L is 3.91 times 10 raised to power 26 4 pi. You have D, which is 5.91 times 10 raised to power 12. Okay, and square it. So if you calculate the value, I have the rounded off value, which is 0.891 watt per meter square, right? So this is a very simple question. You just need to identify your values and identify the formula and just, check what values you have been given and what values you are not given and just get your answer. Okay, so this is your final answer. Okay, so we have this next part right here. It says calculate the time in years that Pluto takes to make one complete orbit of the sun. And you have 1 year converted into seconds, and then you have mass of the sun. Now, as you can see from the question, we don't have much to work with, right? So we have to go with conceptual understanding. Okay, now whenever you talk about like orbit or circular path, right, let me demonstrate it. So you have the sun here and you have this Pluto here, and it is orbiting the sun. Okay, now whenever in a circular path, right, and it is also mentioned in the previous part as well, circular path right here. Okay, so now it is going in a circular path or it is completing its orbit around the sun, right? Whenever this word or this term comes in the question, right, the first formula that should come in your mind is the centripetal force formula, which is F is equals to m mass, right, of the Pluto. Basically, just for now, just remember the formula, right? Mass times angular velocity square r. Okay, this formula, or you can write it in the other form as well. F is equals to m v square by r, up to you. Okay, now this centripetal force formula should come in your mind when you talk about this orbit or the circular path that the Pluto is following. Okay, now if we expand this angular velocity, right, you will know that angular velocity is equals to 2 pi by t, right? So we can get the time from here. Okay, Now, as you can see, we do not have f at all. Okay, so where do we will get this f? Okay, so you can see from the diagram that the Pluto is following this circular path, okay, or making an orbit around the sun. So why it is making that orbit? It is making because of the gravitational force, right? The sun is pulling the Pluto inwards, right, towards itself. Okay, so we can use the gravitational force formula, which is F is equals to G m1 m2 by r square, right? Now this m1 m2 could be anything, mass of the, you can take m1 as mass of the sun or mass of the Pluto, m2 like it's up to you. Okay, now we can use these two formulas, combine them, and then we can calculate this mu value. Okay, because we also don't have mu, sorry, not mu, angular velocity, right? And then from this angular velocity we can calculate the time. Now if we write it simply, right, so it's m angular velocity square r is equals to g m1, let's take it as mass of the sun, and then you have mass of the Pluto, right? This m is the mass of the Pluto in the centripetal force formula, because Pluto is making a circular path, or is basically orbit, making an orbit. Okay, and r square. Okay, now you can cancel these two, mass of the Pluto, right, from both of the sides, and you can shift this r downwards, right? So you're left with, because you need to make the angular velocity as a subject, so angular velocity is equals to square, this square root, sorry, this square shift to the right side, so it becomes square root. So it's g, which is the constant value, mass of the sun, which is, wait, let me write the values of the g as well, which is 6.67 times 10 raised to power minus 11. It's a constant value. And then you have mass of the sun, which is 1.99 times 10 raised to power 30. Okay, and your radius shifted down here, so it becomes r cube. Okay, so it's like r times r times r. So your radius basically is here, written here, which is the mean radius orbit is 5.91, right? So input this value here, so it's 5.91 times 10 raised to power 12, and this is cube. Okay, now if we calculate the angular velocity's value, it will be 8.02 times 10 raised to power minus 10 rod per second. Okay, now you can input the value here and get the time. Okay, so 8.02 times 10 raised to power minus 10 is equals to 2 pi by t. So your t value will be 7.8 4 times 10 raised to power 9 seconds. Remember, the unit is seconds for time. Okay, now we have to convert the seconds into year, right? Because they asked us to calculate time in years. So you calculate time in years, you just divide 7.84 times 10 raised to power 9 by, like, the year, which is 3.15 times 10 raised to power 7. And if you don't know how I got this, it's like very simple. If 1 year is 3.15 10 raised to power 7 seconds, right? So how many years will be, this 7.84 times 10 raised to power 9. Yeah, 9. Okay, so now if you cross multiply, okay, let's take this question mark as x. Okay, x value, x variable. So it will be 7.84 times 10 raised to power 9 equals to 3.15. Okay, times 10 raised to power 7x, right? And then you shift this thing downwards. Okay, because you need this x. Basically x is your time. Okay, just a simple explanation of how I got in this form. Okay, and then if you calculate your time, your value will be 249, or you can say rounded off as 250 years. Okay, so yeah, this is your final answer. Okay,